So yeah, I think we are live. Hi everyone. Very good evening and welcome back to Geeks practice. So guys, please give me a +1 in the chat if all of you can hear me clearly and everything is working fine. So you can react a thumbs up as well in the chat, and I'll then introduce myself and we'll start off. So let me check if we are live or not. Okay, so the audio is also working fine. So yeah, everyone can react a thumbs up in the chat if all of you are ready. And hi everyone, my name is Yash Dwivedi. Currently, I'm working as a software development engineer at GeeksforGeeks, and I teach DSA as well as CP at GeeksforGeeks. I'm a candidate master on Code Forces and 5-star on CodeChef. So all of you can just quickly react, guys, if everything is working fine, and then we can start with the lecture. Okay. So let me quickly share my screen so that we can start discussing the problems. So let's share the screen now. And you can tell me in the comments how many problems you were able to solve. Okay. So let's quickly open the weekly contest analysis sheet. Right. So how many you were able to solve? You can tell me, guys. Let's just quickly open the GFG Weekly Contest. Okay. So, bro, I have solved only two questions. One, first and third one. Okay. No problem, Salish. We'll see how we can solve the problems, right? So yeah, this is the weekly contest, but I know all the approaches of all the questions. Very good. So Arpani says this week seems focus on binary search. Yeah, I can say that second problem can be done using binary search. You all can tell me if you have solved the second problem. So what was your approach? Right. So let's quickly open the problems one by one. I hope that everyone has joined. So you can hit the like button, guys, and react a thumbs up in the chat so that you can tell me if everything is working fine for you, and we'll start with the discussion. Right. So the very first problem that was asked in the contest. So third one, why they gave TT where array was not sorted. We'll discuss about that as well. Okay, we'll discuss about the third question. So how can I increase my implementation skill? So basically, if you want to increase your implementation skills, Amit, then for that, if you want to do better, let's say in GFG weekly contest. So whatever weekly contests have happened in the past, now you can definitely open them directly. Okay, you can easily open whatever weekly contests have happened earlier and try to solve the first two, three, four questions that are there. And by solving the previous contests that have already happened on Geeks for Geeks, you'll be able to improve your implementation skills, because in that case you'll be solving problems that is based on the pattern of the weekly contest. So that's how you can get better. Okay. Yeah, so let's quickly discuss this problem. Okay, so it says that in 2024 the king of Geekland would be decided through the elections. Okay, so there will be some kind of election that will happen, and there are total n people that are there in the voting list, and you are given a binary string. Okay, now in this binary string, if the value of the ith character is 1, so this means that the ith person has voted for geek. And if the ith string is having, if the ith character, let's say, is 0, then in that case you can say that the person has voted against the geek. So what you can do is you are allowed to flip k times. Okay, so you are allowed to flip k characters in the favor of geek. So basically, if there are certain zeros, so what you can do is you can make them ones by flipping them. So let's say if the k value is 3, then you can flip 3 elements. Okay, you can give 3 votes you can give k number of votes in the favor of geek. So what you have to do is you have to tell that whether geek can win the election or not. Okay, and the criteria is that geek should get more votes than his opponent. Okay, so basically whatever votes geek will get, let's say if you have been given the string si. Okay, and let's write this string. Let's say what you have been given is, let's say you have been given the string 1 0, then 1 1, then after that you have been given what, 0 0, then what, 0 and then 1. Okay, let's say this particular string has been given to me. Now in this string, how many votes are there for geek? Okay, how many votes geek is getting directly? 1 2 3 4, because whatever elements are 1, that many votes geek will be getting. So geek is getting 4 votes. Now how many votes are against geek? Whichever votes are 0, that are against geek. So how many votes are against geek? The number of votes that are against geek is 1, 2, 3, 4. So you can say that 4 votes are against geek, right? So if I have, like, if I have another variable that is k, so k value is 3. So I can manipulate 3 votes here. So the total number of votes that geek will get is what? The votes that geek is getting directly plus k number of votes, because you can manipulate these many votes. So that will be nothing but 4 plus 3, that is total 7. So geek is getting how many votes total? Geek is getting total 7 votes. How many elements are there? So total 8 elements are there. So geek can manipulate this element, this element, this element, and then only one vote is against. So the number of votes against the geek will be how much? N minus the number of vote that geek is getting, and then minus with k value as well. Okay, this will be the against vote. So you can see that you can say that geek is getting how many votes? Geek is total getting 7 votes, and the number of votes against the geek are how many? 1. So that's why you will say that geek will win in this case. So that's why you will return true here. So is this question clear to everyone? Yeah, unable to understand the language? No problem, I'll discuss it. So everyone is clear with the explanation of the first problem, how I have tried it? Can you tell me? Right. Everyone is clear with this very basic explanation, that whatever number of vote geek is getting, total number of votes that geek will get is basically the total number of ones in the string plus k votes more, because he can manipulate k votes, right? Then the number of votes against the geek will be total n votes minus the votes that geek is getting minus the k votes that you're going to manipulate. Okay, so the total number of against vote will be n minus the geek vote minus k. So if the geek vote is greater than the vote that he gets against himself, then he will win, otherwise he will lose. Okay, how to improve graph? If you want to improve graph, then you need to solve questions of graph uh, based on difficulty level. Okay, so yeah, what I can say here is, let's say the number of vote that geek will get initially, let's mark it as 0, and now I'll iterate through the string. So we'll say that I starts from 0, then I is lesser than, let's say, the size of the string. So let's say I is less than s dot size. Okay, then after this, guys, what I'll do here is I'll write I plus plus. Now once this is done, then what can I say? If the ith character suppose is equal to 1, then in that case we can directly do geek plus plus. Okay, so we can increase the geek the vote that geek is getting, and then after that we can say that the total number of votes that geek will get is how much? The total number of votes that geek will be nothing but the votes that geek has already got plus k votes that he can manipulate. Okay, and the total number of votes that will be against geek will be how much? Int against the number of votes that are against geek. Okay, so they are going to be nothing but n minus the number of votes that geek is getting minus k, because these many votes you are going to manipulate in favor of geek. Okay, so if the total number of votes that he gets, if it is let's say greater than the number of vote that he gets against himself. Okay, so in that case we are going to return true, else what you're going to do is you're going to return false here. Okay, so this is how you can do it. Let's try and quickly compile this. Okay, because of, yeah, since you have the string now, so you have to use character. Okay, let's try and submit this code. It will get accepted, I hope. Let's see what happens. Yeah, it does get accepted. You can see on the very first go, and the time complexity will obviously be order of n, because we are iterating throughout the string, and the space complexity will be order of 1, because I'm not using any extra space here. So everyone is clear with this question, guys? You can write a +1 in the chat. If everyone is clear, I'll share the submission link as well. Just give me a second. Let me generate the submission link. Okay. So yeah, I have generated the link. Let's quickly share it. Question has not been explained properly. Question has not been explained properly. Okay, I'll explain it again. But guys, do you think that the first question was not explained properly by me? But I had explained it properly. Basically, see, in this case, what will happen is now, like geek will get the string. Okay, when geek gets the string s, so whatever elements are 1, okay, that are the whichever elements are 1, whichever characters are 1, so all those are the votes that are in favor of geek. Okay, then after that, what you can do is you can manipulate k votes in favor of geek. So you can say that k votes more you can add for geek. Okay, so the total number of vote that geek will get is the number of ones that are there in the string plus k votes more, because you can manipulate k votes. So if so, in that case, the final answer will be the final situation is that total number of vote that gets is the number of ones that are there in the string plus k value. Now the total number of votes that are against the geek will be what? The total number of votes that are against the geek will be total number of people minus the vote that geek is getting minus the number of votes that you are manipulating. So the number of votes that are against is n minus geek minus k. So if the total number of votes that geek is getting is greater than the total number of votes that are against the geek, then you'll return true, otherwise you'll return false. So this part is clear. Right. Someone was asking the Behrul. Now you are clear with this particular question, right? Yeah, question 2 has been not explained properly. I also feel that it was not explained properly. I thought that you were asking me to explain this question again. Okay, so yeah, this question was easy and it was clear to everyone. You can hit the like button, guys, if you're clear so far, and then I'll proceed further as well. Okay, so everyone is clear with this now. Second one was difficult. Yeah, I also feel that it was a little bit on the difficult side for some people. What was your approach, guys? Like, for example, for the second problem, I have tried binary search approach, but you can tell me about your approaches. Like, was there any other approaches that you guys have applied for the second problem? But right now, I will skip this problem. Okay, like we will discuss this problem in detail. But before that, let's discuss some more problems. Okay. Yeah, it wasn't explained properly. I also felt a bit that there was some inconsistent consistency in the statement. Maybe it could have been written in a better format. Okay, so can we move on to the next question? Let's discuss the third question for this contest, because if you will see, third question was also pretty good. Right, can we discuss this now, guys? You want to discuss the second one or the third one? Geekland, like Geekland fair, or you want to discuss the strong index? Which one? Second one first. Okay, I'll discuss the second one first in that case. Okay, so yeah, let's discuss about this particular problem. Third, people are saying third, second, third, second, second. Okay, so I'll explain the second one. So yeah, the problem is Geekland Fair, and it says that it is Geekland Fair in 2024, and Geek and Geekina are enjoying the fair. So they are enjoying this kind of celebration here, and they want a juice shop in the fair. Okay, so sorry, they went to a juice shop in the fair, and there are n type of juices, each having k units of juices. Okay, so basically there are n different types of juices that are there, and each of them have k unit of juices inside them, right? So if the like basically there are n types of juices, each having k units of juice. Okay, so if Geekina drinks x unit of juice of any type, assume that Geekina is going to drink x unit of juice of any type, then Geek drinks the remaining k minus x of that type. Okay, so let's say there is a particular juice. Okay, let's say there is a particular juice that is there. Okay, so in that case, if Geekina will drink x unit of that type of juice, then Geek will drink how many? K minus x. Okay, so this is what it is. Basically whatever Geekina will drink now, the remaining will be taken, or the remaining will be drunk by Geek. So given the units of the juices drank by Geekina in the array, so basically in this particular array, what you have been given is, like, you have been given that how many, like, what is the amount of juice that Geekina has drunk. Okay, so basically you have been given what? You have been given the unit, like units of juice drank by Geekina in the array. So whatever juices have been drunk by Geekina, that has been given in the array. So you have to find the minimum value of k, such that the sum of the juices drank by Geekina, so total juice that is drunk by the Geek, it is greater than Geekina. Okay, so you have to decide a value k. Okay, what you have to do is, basically you have been given that how much Geekina has how much juice Geekina has drank, that is given to you inside this array. Okay, The array elements are basically indicating what? You can see this particular line. The end of the second line says that the end, or like basically this particular line, the end of the third line says that given the unit of juice that are drawn by Geekina in the array A. So array A represents what, guys? Tell me. Tell me in the chat. What does the array A represent? Tell me. What does the array A represent, guys? Please tell me in the chat. Array A is representing the unit of juice that has been consumed by Geekina. Is that clear to everyone? Please write yes or no. Is everyone clear with the statement? The array represents the juices that are drunk by Geekina. The amount of the juices that are drunk by Geekina. Make sense? Please tell me yes or no. Okay. Does this make sense? The array is representing the unit of the juices, given the unit of the juices drank by Geekina in the array A. So array A represents that how much juices Geekina has drunk. Okay. Yeah. So basically, in this case, what you have to do is, like, if you have been given the array A, and array A basically represents what? It represents the juices that Geekina has drunk. Okay. So how much, like, total is what? Like, total number of juice that has been drunk by Geekina will be how much? Can you tell me? Total will be how much? Total amount of juice that has been drunk by Geekina will be how much? The sum of this whole array, no? The sum of the whole array, okay, will be the total amount of juice that has been drunk by Geekina. Agree? If I take the sum of the whole array, so that will be the total amount of juice that is drunk by Geekina. Correct? Yeah, correct. Very good. Now, after that, it says that you have to find the minimum value k. Okay. So what you have to do is you have to decide a value k. Like, you have to find the minimum value k. Now, what you have to do is you have to find the minimum value. Okay. You have to find the minimum value k. Okay. You have to find the minimum value k such that what? Such that sum of the juices. Okay. Such that sum of, let's say, the juices is what? Such that the sum of juices drank by geek is greater than the sum by Geekina. Okay, such that the sum of the juices drank by geek is greater than sum drank by Geekina. Okay, this is what you have to find here. Right, and if suppose that Geekina has drunk X unit, so geek will drink how much? Geek will drink K minus X. That is what they have already told you. So can we start discussing this now, guys? Okay, if you will see here, so they are mentioning one thing. Okay, they are always going to mention one thing here. You have to make sure about, like, you have to be very sure about the one thing, that K minus X always needs to be what? K minus X always needs to be greater than 0. See, K minus X always needs to be greater than equal to 0. So X is what? X is the like juice drunk by Geekina. Okay, for a particular quality, for a particular type of juice, X is the juice drunk by Geekina. Okay, and K value, suppose that you have got K, so K units of each juice are there, and you have to decide that what K unit of the juices you need. Okay, you need to decide the value of K, that for every type of juice, what should be the K value, such that if Geekina has drunk X unit, then K minus X should be greater or equal to 0, and you have to find the minimum value of the K. Is this much part clear to everyone or not, guys? Okay, everyone is clear so far or not? Tell me, then I'll explain this problem step by step. Throughout, I'll explain this problem step by step, but if you're clear so far with the basic things, then you can tell me, right? Yeah, I will try to take the example, the first example, possibly, or maybe I'll try to take I'll try to take the first example, the first test case, basically. Okay, Ratul is not clear with some part. You can tell me, Ratul, which part is not clear. If others are clear with the very basic part, with the basic explanation of this question, you can tell me, guys. Okay, because I want to understand that whether you have understood the basic question or not. Basically, you have, like, this particular amount K needs to be decided by you. Okay, X is what? X is basically A of I. For the ith type of juice, X will be A of I only. That has been given in the array, and you have to decide what value of K you can choose such that K minus X is greater or equal to 0, and you have to choose the minimum value of K that can satisfy the criteria. Okay, so many people might have done it using different approaches, but I will, like, suppose that if I did not know anything, so I'll tell you this question in a way that beginners can approach it. Okay, so like you have to always make sure that k minus x should be greater or equal to 0. So what value of k should I choose? Can you tell me? I have to always make sure that the k value will always be greater, like k minus x should be greater or equal to 0. Okay, k minus x should always be greater or equal to 0. So basically this means that k minus a of I, x is what? X is the amount of juices that Geekina is drinking. So x is basically an element of the array. So k minus a of I, k minus any element of the array should be greater or equal to 0. So what should be the minimum value of k? Okay, can you guys tell me? What should be the minimum value of k that I should choose? Can you tell me, guys? What should be the minimum value of k that I should have, such that the k minus a of I is always greater or equal to 0? Can you tell me? If I have been given the array and x is the amount of juice that Geekina is drinking for the ith type, so then you can say that k minus x, in the question they are asking that k minus x should be always greater or equal to 0. Correct? So k minus a of I should be always greater or equal to 0. So k should be chosen as what? At least k should be, like the minimum value of k should be the maximum element of the array, right? Suppose if I have an array which looks like this. Suppose I have an array like 1, 7, 6, and then let's say 4. Okay. So in this case, k minus 1 should be greater or equal to 0. Okay. Then k minus 7 should be greater or equal to 0. Then k minus 6 should be greater or equal to 0. Okay, then k minus 4 should be greater or equal to 0. So what should be the value of k that I should choose? What is the minimum value of k that I should choose? Okay, that I should start from. Can you tell me? If this is the array, then what is the minimum value of k that I should start from, guys? Tell me. Okay, maximum element of the array, right? Because if I keep the value of k as 7, okay, suppose if I keep the value of k as 7, then you can say that 7 minus 1 will be greater or equal to 0. 7 minus 7 will be greater or equal to 0. Okay, 7 minus 6 will be greater or equal to 0. Okay, then 7 minus 4 will be greater or equal to 0. So basically the k value at least will start from the maximum element. Is that clear? Please write mx in the chat. The k value that I'm going to choose, it will start from at least the maximum element of the array. Is that clear to everyone or not? Tell me. Is this part clear or not? Then I'll proceed further. You can tell me in the chat. Quickly tell me in the chat, guys. Is this particular part clear to all of you or not? Okay, you can give me a +1 if you're clear. Okay, you should react in the chat, guys. Okay, is everyone clear with the question? So like this much part. Okay, now let's say, like if you will see here, let's say I have been given the first test case. Okay, so let's talk about the first test case here. The test case is what? You have been given 5, then you have been given 7, then you have been given 4, then you have been given 8. Okay, then you have been given what? 10, then what you have been given? 9, then you have been given 0, and then you have been given 6. Okay, so how much Geekina has, like this is the array that is indicating that whatever Geekina has drunk. So total amount that Geekina has drunk is how much, guys? Total amount of juice that Geekina has drunk is how much? The sum of the array. So this will be 12. 12 plus 6, 12 plus 4 is 16. 16 plus 8 is how much? 16 plus 8 will be, I guess, 24. 24 plus 10 will be 34. 34 plus 9 will be what? 43. 43 plus 6 will be 49. Can I say that the sum is 49? You can tell me, guys. I'm assuming that the total sum will be 49, right? I hope that I am correct. The total sum of the whole array will be 49, I guess. Am I correct? Okay. So in this case, if you will see, I will, let's say if I choose the k value as 10. Okay. Suppose if I choose the k value as how much? Suppose if I choose the k value as 10. Suppose I say that geek is going to, like, suppose that k value is 10. Then what will happen? If you talk about this element, right? So this will be 10 minus 5. Okay. If you talk about this element, so this will be 10 minus 7. This element will be what? Like 10 minus 4. Because 10 is the, like let's say if I'm assuming that 10 is the amount of juice that is total there, and Geekina has drunk 5 unit, 7 unit, 4 unit of each type, right? Then this will be what? This will be basically 10 minus 8. Okay, this will be 10 minus 10, let's say. Then this will be how much? 10 minus 9, guys. This will be 10 minus 0, and this will be 10 minus 6. Okay, if you take the sum, so basically whatever sum you will get now will be the sum that is drunk by geeks. Okay, k minus a of I, a of I is the amount that is drunk by Geekina. Okay, a of I is the amount that is drunk by Geekina, and total amount of juice for a particular type is k. So the amount that will be drunk by geek will be the leftover amount. So leftover amount is k minus a of I, because k I am assuming is the amount of juice of a particular type. Okay, so then what is the total sum here? You can see I'll get 5 from here. Then I'll get 3 from here. I'll get how much from here? 6. Then I'll get 2 from here. I'll get 0 from here. I'll get 1 from here. I'll get 10 from here. I'll get 4 from here. So what is the total sum? 5 plus 3, 8. 8 plus 6 is how much? 14. 14 plus 2 is how much? 16. 16 plus 1, 17. Right. Then 17 plus 10, 27. 27 plus 4 is how much? 31. So then you will say that geek will drink how much in total? Geek will drink 21 units. So if I choose the K value as 10, is geek drinking more juice than geekina? Tell me. If I choose the K value as 10, so the total amount of juice that geek will drink is 21. So is geek drinking more than geekina? Yes or no for this test case? Tell me. If I choose the K value as 10, if I say that every juice was present 10 units each, okay, then geekina has drunk 5, 7, 4, 8 respectively. Then the amount that geek will drink will be 10 minus 5, 10 minus 7, 10 minus 4. So I'll take the sum of all the yellow elements that I have written. That is the differences. And that amount I'll get is 21. So geek is not going to drink more than what geekina has drunk. Correct? You can tell me in the chat, guys. Does this make sense or not? Okay. So geek, yeah, 31. Okay, 31 units. Sorry. Thanks a lot for correcting. I guess it is 31. Thanks a lot. Right. So like is geek drinking more? Is geek drinking more than geekina? Tell me. Even if it is 31, actual sum is 31. Thanks a lot for correcting. But is geek drinking more than geekina? Yes or no? No, geek is not drinking more than geekina. So will this K work for me? No, it will not work for me. Okay. So I need to choose another K. Okay. So then what I'll do is I'll say that, okay, instead of this K, what if I choose another K? Okay. So what if, let's say, if I choose another K as what? Let's say if I choose like instead of 10, if I increase the K value to 11, what if my K is 11? If every juice is present 11 unit, okay, then geekina has drunk 5 unit, 7 unit, 4 unit. Then 11 minus 5 will be how much? Like this will be 11 minus 5, 11 minus 7. This will be 11 minus 4, guys. This will be 11 minus 8. This will be what? 11 minus 10. This will be 11 minus 9. This will be what? 11 minus 10, like 11 minus 0. Okay. Then this will be how much? This will be 11 minus 6. So now this value is how much? If you will see here, this will be 6, this will be 4, this will be how much? Let's say 7, I guess, right? This will be 3, this will be how much? 1, this will be 2, this will be 11, this will be 5. So total sum will be how much? 6 plus 4, 10, 17, then 20, 21, 22, 23, 23 plus this thing, 28, 38. So geek will total drink how much unit? Geek will total drink 38 unit. Okay, because geek will drink the remaining amount. Na? If every juice is present 11 units, okay, if I'm assuming that every juice is present 11 units, now geek is doing what? If every juice is present 11 units, right, and geek is then geekina has drunk 5 unit, 7 unit, 4 unit, then the remaining will be drunk by geek. So geek will drink 11 minus 5, 7 minus 11 minus 7, 11 minus 4. So total sum is 38. So sorry, 39. Yeah, thanks a lot for correcting again. So yeah, let's say the total sum is 39. So will geek drink, like, is geek able to drink more than geekina? Tell me. If I, yeah, thanks a lot for correcting. Don't go on my calculation, go on the observation. Okay. And if you're clear with the observation part, you can hit the like button, guys. So yeah, you will see, is geek able to drink more than geekina? Tell me, is geek able to drink more than geekina? If every juice was present 11 liters, let's say, so is geek able to drink more than geekina? No, he is not. Right, he is not able to drink. Then after that, I'll check for the, see, I have checked for K is equal to 10. Okay, for K is equal to 10, I was not able to do the job. Okay, then for K is equal to 11 also, it is not working for me. Okay, when I chose the K value is 11, it is not working for me. Right, now I will do what? I'll choose the K value as 12. Okay, let's see if every juice is present 12 unit each. Okay, if I'm taking 12 liter of every juice and geekina has drunk this much, then let's see what will happen here. Okay, so if you will see here, let us say in this case that you will have what? You will have 12 minus 5, then what? 12 minus 7, then what? 12 minus 4 here, then what? Let's say 12 minus 8, then this will be how much? 12 minus 10. Okay, this will be how much? 12 minus 9, this will be how much? 12 minus 0, then this will be how much? 12 minus 6. So you can see here that what are the values, right? So here this will be 7, this will be how much? 5, this will be basically 8, this will be what, 4, this will be what, 2, this will be what, 3, this will be what, 12, this will be how much, 6, right? Now if you see here guys, so what is the sum? 7 plus 5, 12, right? 12 plus 8 is 20, 24, then 25, 26, 27, 28, 29, 29 plus 18, so 29 plus 18 is how much? I guess this would come around 47, right? So yeah, then Geek will drink how much? Geek will drink total 47 units, right? If every juice is present 12 liters, okay, suppose that every kind of juice is present 12 liters, and Geekina is drinking 5, 7, 4, 8, 10 respectively, then the amount that Geek will drink will be how much? Will be 12 minus 5, 12 minus 7, 12 minus 4. So if I take the sum of that, so this is how much? This is 47, right? Now if it is 47, is it greater than 49? Am I able to drink more than Geekina, guys? Tell me, am I able to drink more than Geekina or not? Yeah, it is binary search or answer. I understand, Ratul, but basically I'm trying to explain the intuition to everyone. For those who are not able to understand, for them I am trying to explain this thing. Okay, so yeah, like then it is 47, right? So is Geek able to drink more? No. So then you'll say that this is also not satisfying the criteria. Then I need to go forward. I need to increase the value. Okay, if you respect my effort now, you can give a thumbs up to the like, you can like the video guys, and you can genuinely give a thumbs up in the chat. You can react +1 in the chat if you're clear so far, because I'm trying to explain the question statement also, which is not very clear from the problem statement itself. Correct? So you guys can tell me if you're clear or not. Okay, then after that I will do what, I will choose the next value. Okay, thanks a lot for the support. Okay, so yeah, if you will see after this, what I'm going to do is, after this I'll choose the k value, let's say as 13. Okay, if I choose the k value as 13, so like if I am saying that now every juice is present 13 units each. Okay, every juice, let's say, is present 13 units, then Geekina is drinking how much? Geekina is drinking let's say 5 unit, 7 unit, 13, 4 unit, 8 unit. So this will be what? This will be 13 minus 5. This will be what? 13 minus 7. The amount that Geek will drink. 13 minus 4. Then this will be how much? 13 minus 8. This will be how much? 13 minus 10. This will be how much? 13 minus 9. This will be how much? 13 minus 0. This will be how much? 13 minus 6. Now, what is the sum that you're getting here? Let's try and find it. So the sum that you'll be getting here is basically you'll get 8 here. You'll get how much here? 3 and 3, 6, right? So then you'll get how much here? 9. Then you'll get how much here? 5, right? Then you'll get how much here? 3. You'll get how much here? 4. Then you'll get how much here? 13. Then you'll get how much here? 7. So if you add this up, how much is the sum? So 8 plus 6, 15, right? Sorry, 6 plus 8 is 14, right? 14 plus 9 will be how much? 14 plus 9, I guess, is 23. 23 plus 5 is 28. 28 plus 3 is how much? 28, let's say 28 plus 7 if I do. So 28 plus 7 is 35. 35 plus 20. 35 plus 20 is 55. So Geek will total drink how much? 55 units, right? Geek is going to drink 55. Is Geek able to beat Geekina? Yes or no? Tell me. Is Geek able to beat Geekina? Yes or no, guys? Tell me. Is Geek able to beat Geekina or not? Yes, Geek is able to. Not everyone understood. But I'm trying to explain the problem statement, na Shailesh. So if you are able to understand this one, you can tell me, right? So yeah, you can see that k is equal to 13. For k is equal to 13, it will work. Okay. If you choose k is equal to 14 also, it will also work. If you choose k is equal to 15 also, it will also work. K is equal to 16 also, it will also work. But you need to find the minimum value, because the question says that what you have to do is you have to find the minimum value of k. Okay. You have to find the minimum value of k, and the minimum value is 13. Normally I'm doing what? I am applying linear search, correct? Normally what am I doing? I'm looking for 10, whether it is satisfying or not, then 11, then 12, then 13. So normally I'm going step by step. How I can take that value? So basically k will be, at least k should be equal to the minimum element of the array. No? At least k should be the minimum element of the sorry, at least k should be the maximum element of the array, because Geekina will at least drink like at least 10 unit of juice should be available. Na? Then only Geeky, if you see this element, so this particular element is what? This particular element is basically 10 here, right? Now, since this particular element is basically 10 here, so in this case, you can see that Geekina must have drunk at least 10 units, right? That is why these 10 units, like if this is 10, this means that 10 units must be at least present. So that's why you need to start your K from 10. That is the maximum element of the array. So is that clear, Hitesh? Like you will start K from 10 and then you will keep on searching. Normally, this is what you will do, but linear search will take more time. Instead of linear search, what is better? Binary search is more better. Are you getting my point? Because like if you have a particular K, let's say you have chosen a particular K, okay, like you have a range, right? So what is the lowest range that you can have? If you see the lowest value of K that you can have is how much? The lowest value of K that you can have is the maximum element of the array, right? So maximum element of the array, so basically that in this case that will be, let's say, 10. Okay, and what is the highest element that you can choose? Highest value of K. So if you want to choose the highest value, so you can assume it as anything, but it will be obviously if the lowest element is, like, see, lowest value of K can be 10, so the highest value can be anything, right? For example, you can see that the problem satisfies on 13, so maybe I can take highest value as 2 times the maximum element. Okay, because you will not require more than this. Okay, like highest element you can take as the max 2 times the maximum element, so then highest you can take as 20. You can keep the search space between 10 to 20. Are you getting my point, guys? Yeah, you can choose the upper limit as anything. You can choose it as 2 times the maximum element, 3 times the maximum element. It doesn't really matter here. Basically you can choose 2 times the maximum element or 3 times the maximum element, because if you see here now, if you look at this test case also, so you can see that 13, 14, 15, everything is satisfying, right? So you can understand by looking at this test case itself, that if you choose 2 times the maximum element, then it will satisfy. Obviously it will satisfy, because you're choosing twice the maximum element. Okay, so if you subtract throughout the array, so you'll get a very big sum, which will obviously be greater than the sum of the array. So that's why choosing 2 times the maximum is the highest that you can choose. Make sense, guys? You can choose it as anything, but yeah, this thing is comfortable, I guess. Right. Then after that, if I am at a particular mid, okay. So if that mid does not, like, if suppose that if I'm at a particular mid, okay, mid is basically indicating the current K. If it does not satisfy, okay, if the sum that geeks get with respect to this mid, okay, if the sum that geek gets, okay, if it is lesser than equal to geekina, then what you will do? Then if this mid does not satisfy, no, then all the things on the left side will also not satisfy. If this mid, if I'm trying to choose this mid value as K, okay, as the amount of liters for every type of juice, and if it does not satisfy, then all the elements on the left will also not satisfy. This means that I need to think about a higher capacity. So in that case, I'll mark my low as mid plus 1. So I'll say that I'll search from mid plus 1 till the end. Okay, I'll search from mid plus 1 till the end. Does this make sense, guys? Yes or no? Okay. Otherwise, otherwise, what you can do is you can choose it as anything, right? How am I choosing this? Das Gupta is asking. Basically, Das Gupta, you can understand one thing now. That suppose that you have, like, if you have the array, right? If you have the array which has the value as 10, so if you don't want to choose it as 2x, let's say I can choose it as 4x. Instead of 2x, choose it as 4x. Like, you can choose it as anything, but let's say if you choose it as 4 times the maximum element. Okay, so if you choose this as 40, you can see now, like, you can see in this question, if I choose like, every element is present 40 unit each. So if you will choose 40 unit, then obviously whatever geek will get will be more than what geekina has drunk. Correct. So you can see 40 minus 5, 40 minus 7. So normal couple of additions will give you more sum than geekina, right? Only adding one or two elements differences will give you more sum than geekina. So that is why you can choose it as 4 times the maximum element. So does this make sense, or not? Okay, everyone, tell me. So yeah, basically, if the mid that you have chosen, okay, if it does not satisfy, then you'll search on the right side. So you'll mark your low as mid plus 1. Okay. Otherwise, suppose that the mid that you have chosen, if it satisfies the criteria. So if this mid is able to satisfy, then you'll store this as the answer, and you'll try to look for a smaller guy. Okay, you will store this, that yes, this is my answer, but can I get something much lesser than this? If I want something lesser, so I'll search on the left side. So I'll mark my high as mid minus 1 after storing this answer as mid. So is that clear to everyone, guys? Tell me. Is this particular condition clear? And the question statement is also clear, and how the binary search intuition comes. Everything is clear here or not? Tell me, guys. Are you all clear with this part? If yes, then you can hit the like button and you can give me a +1 in the chat as well. Does this make sense throughout? for everyone. Okay, so yeah, let's say that what I'll do is I'll take a long sum variable. Okay, like let's say Geekina variable. Okay, Geekina to Geekina will be basically the total that Geekina gets. Okay, and then I'll also take a maximum variable. So let's say long mx is the maximum element of the array. So let's say it will be initially a of 0. Okay, then I will iterate throughout the array. So I'll say that int I starts from 0, I is let's say lesser than n, then I'll do I plus plus, right? So the test case 1 0 should be 0. Please explain which test case? The next problem you are asking, Amit, which problem? Second problem or third problem? Can we take the upper limit of BSD? Upper limit of BSD as sum of array is 49. Can we take upper limit? Like you can take it 4 times the maximum element, 5 times the maximum element. That would work. Okay, you can check this. Okay, second problem. What are you saying? Second problem, which test case? Second problem is this one only now. So here there is nothing like test case 1, there is nothing like 0. What are you saying? I'm not able to understand. If we take 0, then the answer should be 1. So yeah, that is why I'm choosing 4 times. But actually, if you will see if you will see this, so you have this between 0 to this thing. So if assume that this was the case, right? So if every element is 0, basically in that case, suppose that if every element is 0, Geekina is there. So Geekina, then yeah, this might not work, but yeah, like this is fine. Like uh, in that case, you can choose the low as yeah. So if every element is 0, suppose in that case, you can say that the low will be 1, at least 1. Yeah. So you can do that if you want. Fourth is wrong. Constraints, but test case includes n is equal to 1. I have not checked it. Exception case. Yeah, basically, yeah, you can like it's a very good thing that you have thought about it. So I'll consider that while writing the code also. Okay, sum plus is equal to what? Sum plus is equal to let's say a of I. So I'll take the sum and maximum is equal to what? Max of the maximum comma a of I here. Now after that, I'll say that the low will be how much? So let's say long the low value will be nothing but it will be the minimum like it will be the maximum of 1 comma what because if suppose that the maximum element of the array is 0, okay, in that case you need to mark your low as at least 1. Okay, so you can do something like this if you want. Okay, then let's say long high will be how much in this case. Let's say I can say that what I can do is let's say if the maximum element is 0, if you want to do this, then you can mark the maximum as 1. That will work. Okay, now you can update later on. So yeah, long let's say low value will be what? Low will be nothing but the maximum element. Okay, the lowest that you can choose is maximum, and the highest that you can choose, let's say, is 4 times or 5 times the maximum. Okay, because it is too much, but 4 times maximum is too much. Even 2 times maximum would have worked, but still I'm saying that let's choose 4 times maximum. Okay. In the question, there is strictly increasing mention. Which question? Okay, yeah. So this is the case. Then after this, I'll mark my long. Let's say answer as what? 0. Okay. Then I'll say that while the low value, let's say what I can do here is I'll say that let's say while the low value is lesser than equal to the high. Okay. Till that point of time, you can iterate, and then you can say that let's say long mid will be how much? It will be low plus high minus low by 2. So you can find out the midpoint like this, and then you will write a check function. So you'll write check, and in this check function you'll pass the array A, you'll pass the sum Geekina, you'll pass the length of the array, then you'll pass what? After passing the length, you'll also pass the Geekina sum, and then you'll pass your mid. Okay, and if it returns a true that yes, this mid was able to satisfy. Okay, if this particular mid is able to satisfy, then you'll say that r is equal to mid minus 1. Okay, otherwise if it is not able to satisfy, then you'll say that low high is equal to mid minus 1 if it is able to satisfy. Otherwise you'll say that low is equal to mid plus 1. Okay, and at the end you're going to do what? You're going to return the low value. Basically, what is the lowest possible value that is satisfying the criteria. Okay, Yeah, 2 times max. Yeah, 2 times max is also fine, but for security purpose, I'm taking 4 times max. But 2 times max will also work, but I have to derive it mathematically, so it's better to take 4 times max. Okay, so yeah, this is what I can do. Now I have to write this check function, right? So let's write this check function here. So you'll write, let's say, bool check function. Okay, then here I'll be passing the array. So let's say I'll pass vector int, let's say ampersand a. Then after that, what will I pass? I'll pass after the array, I'll pass the geekina sum. Okay. Okay. Then after that, what will I pass? I'll pass the n value, and I'll pass the long mid also. Right. So yeah, now after this, what I'll do is I'll say that the sum that geek will get is how much? Initially 0. So let's mark this as long. Okay. So yeah, long, the sum that geek will get will be 0 here. Now after this, what I'll do is I'll say that int, let's say I starts from 0, I is lesser than n, then I plus plus. Now this mid is the amount that I have chosen, mid unit of juice everywhere, of every type. So in that case, the amount that geek will get is how much? Geek plus is equal to basically this amount, total amount of juice of a particular type minus whatever geekina has drunk. So this will be mid minus a of I. Okay, and then after that, I'll check what? I'll check that if geek is drinking more than geekina, right? Because the sum that is drunk by geek is something that I've stored here, and whatever geekina is drinking, I already knew that, so I've passed it here. Let's use long. Okay, so if this is satisfying, then I'll return true. Otherwise, if it doesn't, then I'll do what, guys? I'll be returning false here. Okay, so does this? I know that it can be done very easily. I know that, but still, if you will ask me, so I would have done it like this. Okay, I understand your formula, but yeah. So let's use geekina variable here. Right. So are you clear so far, guys? Yes or no? Tell me. Let's try and see what is the mistake. So yeah, max mx. So let's use something like int here, and then later on we can use this thing. Yeah. Let's see what happens. So yeah, you can see it works fine for the samples. It is working fine. Let's try and submit this. It should get accepted, I hope. If it doesn't, we'll check, but hopefully it should get accepted. Okay, it doesn't work, right? Its correct output is this much. Okay, for some weird reason, my code is failing somewhere. So let me just check where it is failing. For very high values, it is failing, right? So if I would have chosen 2 times max, that like still it might give an error. Like obviously, if it is given an error, it can give any time. But let's see. Okay, it works, right? So yeah, 2 times. If you choose 2 times, then okay, let's say if you choose 3 times. So let's see if that works or not. 4 times, I guess, is too much. So it might be exceeding the limit of long. Yeah, you can see if I choose 3 times, then it is exceeding, I guess. So, but if I choose 2 times, it is not exceeding. Okay. So if I choose 2 times, then the answer is coming correct. Right, yeah. So it works. So high can be chosen as 2 times the maximum value, right? So, or possibly, I guess the mistake that is there, like you can choose it 4 times, but you have to do one thing. You have to take this as long. Okay. So you have to typecast this as long, then it would work. Basically, integer into 4 might have, like, suppose that mx is like, why my case was failing, I'll tell you. See, I was trying to do high is equal to 4 into mx. Now, if this is an integer now, so this overall all will be an integer, right? So that's why what I need to do is I need to typecast this, like suppose this is very high, so very high integer, very high value of integer into 4, it can overflow. Okay, it will overflow. So that's why what is better is if I do what, high is equal to 4 into long mx. Okay, if I do 4 into long mx, then what will happen? This will become long into 4 will not overflow, long will not overflow. So that's why if I do long into 4x, then it will work. Okay, let's submit this now. So you can see that it will work now, right? Let's see. Yeah, you can see it gets accepted. So is this problem clear to everyone, guys? Yes or no? Tell me. Are you all clear with this approach, guys? Okay. For one particular mid, okay, for one particular mid value, you are running order of n time for the check function, guys, right? You're running throughout the array for the check function. And the bind search is running how many times? It is running log n times. let's say log, roughly what you can say, roughly it is running for log of high minus low value, right? Let's assume that high minus low that I have chosen, it is equal to m, capital M, suppose. Okay, so if it is running log of m times, suppose, in that case, this will be n into log of m. So this is the time complexity for our code. Okay, makes sense, guys? If everyone is clear, you can tell me, right? If you're not clear, you can tell me about that also. But I hope that mostly people are clear. You can give me a +1, guys. Are you clear with the question statement and everything throughout? Yes or no? Got it, Hitesh? Everyone who got it, you can react a +1, and you can you can write understood, guys, in the chat. Okay. I hope that you've understood it. I've tried to explain it a lot from scratch. Okay. And you can give, you can like the stream, guys, if you have understood this clearly. Okay, everyone should react, and everyone should tell me whether they are clear with this basic understanding or not. Okay, so basically whenever you have to see, there can be many values. Now I'll tell you, basically, if you will see here now, you should not stop after solving this problem. Okay, because basically there can be a lot of k values. For example, k is equal to 13 was satisfying, k is equal to 14 was satisfying, k is equal to 15 was satisfying. So you have to do what? You have to minimize. You have to minimize the maximum value of k. Like minimize the maximum here, minimize the maximum value of k. That is what you were doing now, right? If you want to solve similar problems, so I'll recommend you some of the problems. Okay, for example, if you will solve cocoa eating banana problem, that is there. If you want to solve more problems on this kind of binds, I didn't use bind search but the formula. So yeah, Jay, it depends now. Like, see, if I it's about intuition. Sometimes your brain is sharp, sometimes your brain hits certain kind of criteria, then you're able to think bind search. Sometimes you are able to think mathematically, so it depends, right? uh, it's difficult to find a formula normally. No, if you agree, you can tell me, guys. Normally, if I'm a common man, so a formula doesn't hit my mind normally. It doesn't, to be very honest. So that's why I always try to go with the old school approach. Okay, so yeah, cocoa eating bananas problem is there. Okay, if you want to try this problem, you can try. Then after that, you can try capacity to ship within d days. Okay, capacity to ship within d days. You can try this problem also. Then if you want, these are all bind search on answer problems. Okay, these are all bind search on answer. Okay, then if you want, you can try what, let's say you can try minimize maximum allocation of pages, as something like that. Okay, then you can try one more problem, that is bike racing, geeks for geeks, bike racing GFG practice. Okay, then you can try out maximum split sum also. It has been asked in Google. So there are a lot of problems that are there. You can try them out, okay, if you want. Aggressive cows. Man, go for try. Yeah. Yeah, you'll be good. Obviously, if you practice, you'll be good. So yeah, you can, if you want, you can try these problems out, okay, on your own. Okay, guys, can we move forward now? I hope that we can. Right. So let's try and move forward. So second one, I thought it was a bit difficult to understand. Right. But yeah, if you're ready, you can write next in the chat, guys, and then I'll move on to the next problem. Can we move on to the next problem now? If everyone is ready for it. Okay, you're not okay. So the next problem is basically named as strong indices. Everyone has understood the second problem clearly, no? Right. I hope that everyone has understood the second problem absolutely, from the scratch, from grassroots level till the advanced level, right? Yeah, so let's see what is the third, what does this question say here? Okay, it says that you have been given two sorted arrays. Okay, so basically the question says that you have been given two sorted arrays. Okay, so you have been given two sorted arrays, and the array, one array is, let's say, array A, another array is array B. Okay, then what are they saying further? They are saying that having n elements each. Okay, so both of the arrays have m elements each, and you have been given two integers x and y. Okay, so there are two integers that are given to you. One integer has been given as x, another integer has been given as y, and you need to find the number of indices. Let's say if there is a p index. Okay, p and q are indexes. Okay, these like p and q, these two values are what? These are indexes. Okay, indexes inside the array. You have to find the indexes such that you can make a strong pair. What is the definition of a strong pair? So for making a strong pair, the scenario is that you have to choose you have to choose a particular element, let's say q. So you have to choose a particular element bq. Okay, in the array b you have to choose a particular element at the index q, such that it is less than equal to what? It is less than equal to a of p plus y. Okay, and it is greater equal to a of p minus x. Okay, is this much part clear to everyone? So basically this is a two pointer question. Is the statement clear or not? Third question, test case was wrong, I tried pointer approach for it. I don't think that it was wrong. I didn't felt anything like that, because I tried from the very basic method. So basically, if suppose that you have a certain index, okay, if suppose that there is a index p and there is a index p and there is a index q which satisfies the criteria. Okay, suppose that it satisfies the criteria of being a strong index, such that strong pair index, such that the index p and index q are satisfying this equation. Then you cannot use those indexes again. It says that find the maximum number of strong indexes that you can make, such that p is an index of the array A and q is an index of the array B, and any index from array A can be matched to at most one index of B. So basically one index of array A can be used to match with one index of array B. Okay, so one index of an array can be used only one time. And one index of array B can be used only one time. Does that make sense? Okay, suppose that there is index 3 from the first array and there is index 5 from the second array. So once you have used this now, then you cannot make a pair of this kind. Then you cannot make a pair of, let's say, what? Then you cannot make a pair of 4 comma 5. You cannot do that, because if you have already used 5 here. Okay, does that make sense, guys? You can give me a +1 in the chat. If the test cases were not sorted, then that is not good. So Ankit is saying test cases were not sorted. So test cases were not sorted. Guys, internally the test cases were not sorted. Like someone is saying that one of the test case was not sorted. Is that so? Okay, so how can I solve this particular problem, right? So what you can do is, let's say if you have to solve this, so you can basically apply a simple, very easy to do two pointer approach here. Okay, like what I can do here is, let's say if I have to choose, right? So let's say if I want, I can choose an index q, let's say initially as 0. Okay, then I can choose an index p initially, let's say as 0. Then I can say that while my because if you'll see here, so I always have to choose a particular q, right? So in that case, I have to decide that which pointer I will be like uh, whether my p satisfies or not. Okay, if my current p is not able to satisfy with respect to this q, then I'll try to move. Okay, so let's say that what I'll do is I'll basically say that my p is less than n, because I want to find the maximum number of pairs, guys. Okay, you have to understand one thing, that I need to find the maximum number of pairs or the maximum count. So initially I can mark my answer as what? Let's say 0. Now after that, what I'll do here is whenever I am at a particular element, let's say, okay, so whenever I am at a particular element p, so for whenever I am at a particular element p, let's say, so I'll try to make this p pair with a particular q element of the array. So I'll say that let's say while the q is lesser than n. Okay, and at the same time, what? Let's say the q is less than n, and there should be one criteria, that is b of if suppose that what I'm doing is, let's say if I will check this equation, right? So b of q is there. So let's say if b of q is there, okay, and if the b of q, if it is less than a of I minus x, then what should I do, guys? Tell me. If the b of q is less than a of I minus x, so basically I have to choose a b of q such that a of p minus x. So if suppose that a of p minus x, if it is greater than a of b of q, because you will see here, I'm talking about the first part. I'm talking about the first segment here. Look at this equation. Let's say if I have got what? If I have got this much segment. Okay. If you talk about this much. So basically, when can I think about a particular p? Like when can I think about a particular q? So basically, whatever q I am going to choose now, that b of q should always be greater equal to. Okay, it cannot be less. If the b of q, if it is less than a of p minus x, then I should always do q plus plus. Okay, I should move to the next q. Does that make sense, guys? Please tell me. If the q does not satisfy the very basic criteria, the first part of the equation, then I need to move my q forward. Does that make sense, guys? Yes or no? Tell me. If the q does not satisfy the very starting criteria, that if b of q, if in the side the second array, the element at the index q in the second array, if it should be greater than equal to a of p minus x. So if it is less than a of p minus x, then I should update. Does this make sense, guys? Okay, so I should do q plus plus here. I hope that this particular part makes sense for everyone, right? This particular part makes sense, guys. Now after this is done, now then I'll check what I'll check is, I'll check that after that if my j is less than n. So if my j follows the criteria, okay, and at the same time what happens, now I'll check that if b of q should be what, it should be less than equal to a of p plus x now. So if it satisfies the second criteria, first of all I'll make sure that b of q is always greater equal to a of p minus x. If it is not, then I'll increase my q. Then after that b of q will be standing at, like after this what will happen, after this you can say that b of q, it is obviously, it is greater than equal to a of p minus x. It is greater equal to this value. Now I have to check that whether b of q, it is less than equal to a of p plus y or not. Okay, so if it is, then I'll say that I need to add this in my answer, and I'll increase the j value. Sorry, I'll increase the q value. Sorry. So yeah, I'll increase the q value. I'll say that since this pair has been made, so I'll move to the next guy. And outside this loop, what I'll do is I'll do p plus plus as well. Okay. And then at the end, I can simply return my total count. So I'll return the answer here. Since I want to make the maximum number of pairs, that is why I'm starting my p and q from the starting. So does this make sense to everyone, guys? You can tell me. Is the idea clear or anything is not clear here? No, no, there is nothing like J. I had mistake. I had written it by mistake. So I hope that now it makes sense for everyone, right? And to and okay, yeah. So I'll change it to and yeah. J. I hope that I have not written J anywhere else, right? I have a habit of writing IJ, but this question was asking for P and Q, no? So our like Pawan, basically Pawan. If you will see here now, so I am making sure like I'm checking this part here. Basically, if my b of q, if it is like, see, if a of p minus x, if it is greater than b of q, then I'm always increasing the q value now. So then this q value like it is always getting increased. So last time either it will exhaust, either it will get exhausted, or I will stand at a b of q which is greater equal to a of p minus x. So this loop will help me to tackle that condition. Okay, are you getting my point? Okay, if because I have two parts of the equation, right? The first part is that b of q that I'm choosing, it should always be greater equal to a of p minus x. Correct, that should be the criteria. So in that case, what will happen is, if suppose that b of q is less than a of p minus x, it should be either equal or it should be either greater. If it is less, then I'll make sure that I keep on increasing my q. Okay, and once that is done, then I'll check that if my p is under control, and at the same time what happens, that the other condition is being satisfied. The other condition is what? The other condition is that b of q is less than equal to a of p plus y. So this particular condition, then I'll say that yes, this is another pair. I'll choose this, and I'll say that I'll do q plus plus, and every time I'll keep on increasing my p. Make sense, guys? If you're clear, you can tell me. I hope this does make sense. And if you will see, so basically, what's the worst case time complexity? If you have got this array, so in the worst case, my p pointer will be iterating throughout the array. Okay, and my q pointer will be iterating throughout the array. So it will be basically order of n plus n. So basically, it's order of n overall time complexity. Does this make sense, guys? Okay, does this make sense? You can write clear in the chat, guys, if you're clear with this. Okay, everyone is clear with this? And you can hit the like button as well. The number of likes are less compared to the effort that I'm putting here. So you can tell me, guys, right? Does this make sense? I hope you have understood it. Okay, so let me just copy this piece of code and I'll share it with all of you. So yeah, let me share this right here. Okay, so far everyone has enjoyed. Tell me, so far everyone has enjoyed the discussion, right? The third problem was very easy compared to the second one. At least that is what I felt, because the first problem statement was a bit difficult for some people, and maybe for me as well. Okay, so everyone is enjoying so far. Tell me. Then we'll start with the next question within the next 1 minute. So, are you watching IPL or not, guys? Okay, let's move forward now. No IPL. Why not IPL? Okay. So yeah, who are you supporting? Let me check the score now. Okay. So yeah, SRH is 113. So I guess KKR is going to win, right? Okay. So yeah, can we proceed further? Okay, let's proceed further then. You can hit the like button for at least for KKR, if not for me. Okay. Everyone is ready for the last question, guys. Okay. Geekland is haunted. Okay. Okay, Geekland is haunted. This is the problem name. Okay. And it's a graph based problem. You can understand it by looking at the problem itself. So it says that Geekland is a kingdom with n cities. So how many cities are there? N cities are there. Okay, let's write the information one by one. N cities are there in Geekland. Okay, and some of the cities are haunted. Some of the cities are haunted. Okay, then after that it says that the cities of Geekland form a structure of tree. Okay, so basically this is a tree based problem. So the cities are arranged in form of a tree. Okay, the cities are arranged in form of a tree. Okay, in form of a tree here. Right, next up it says that uh unfortunately the queen of Geekland lives in the leaves. Okay, so the queen are living where? Queens are living in the leaf. Okay, all right, so queens are living in the leaf cities. Okay, can't we solve it using my search? Which problem? This one, Akansha Pandey. Like you can solve it using simple recursive DFS approach, no? Why do we need to apply buying search here? Because this is a straightforward tree problem. Okay, so yeah, the cities. Which one? You are talking about the third problem. If you're talking about the third problem, then you can solve the third problem, I guess, using buying search. But buying search would take n log n time. If buying search is applicable, even it would take n log n time, and that is not good, right? So two pointer is best. But maybe you can solve it using buying search. I did not try buying search for the third problem. I just did what the statement was asking in the third problem. Okay. So yeah, if you see here, it says that Geekland is a kingdom with n cities. Okay, queens are in the leaves. That is fine. Then after that, it says that Geek cannot go through m consecutive haunted cities. Okay, So it says that geek cannot go through m consecutive haunted cities. Okay. So geek cannot go through m consecutive haunted cities. HAUNTED. Right. Yeah. Right. Next up, it says that so you cannot, like, the moment you go to consecutive M haunted cities, then you have to stop. Okay. Then Geek wants to know that starting from the capital city, how many leaf cities he can visit and meet the queens. Okay. So you're going to start from the capital city, and whether a city is haunted or not is given in the haunted area. Okay. So there's a haunted area that is given to you, and the edges between the cities are given. Okay. So the vertex is one. So basically, one, the city that is given as one, it is the capital city, I guess, right? Capital city, you can say, or you can say the root of the tree, basically. Root of the tree. Okay. Right. Root of the tree. Okay, now let's start discussing this further. For third problem, yeah, I heard that if the test case, like, I heard that there was a test case in which sorting was not done in the array. I'm not sure, I've not seen that test case, but if that is so, you can tell us about it. Okay. So yeah, let's say you have got this particular array, right? So let's say you have got what? Let's say you have got one. Uh, okay, this particular house number one. Then what? House number two will be connected here. House number three will be here. Okay. Then house number four is connected directly like this, and house number five is connected like this. Okay. And you cannot visit more than one haunted house. Remember. Okay. So yeah, if you will see here, if you start from here, right? Then let's talk about the haunted house also. So I guess one is haunted. Okay. So one is haunted. Not haunted. This is not. This is also not like three is haunted or not. Three is haunted. Yeah. Three is haunted. Four is haunted or not. Four is actually not haunted, so not haunted. Okay. Then five is haunted. Yes, five is haunted. Okay. So you cannot go through more than one haunted house. Okay. So if you start from here, okay, guys, understand this thing. If you start from here, so right now your counter will be how much? Like, you will say that your counter will become one. You are in one haunted house. Now after that you will go down here. So when you go to this house, is it is this house haunted? No. And is it a leaf? Yes. So in that case, you can say that you reached this house and you visited not more than one haunted house. So that is fine. So you'll say that you'll count this guy. So your answer will become one here. Then after that, your count was one here. Now you went down, so you went to this house. Now this is haunted, so your count will become what? Two total. So since your count is two, so you have gone, like, you should not go through more than one haunted house. Okay, you should not go through more than one haunted house, but you have gone. So that's why this will not be counted. Then when you go from one to four, so then the count will be still one because the house number four is not haunted. So then you can say that you have gone through a queen again, and you are able to reach without going through more than one consecutive haunted house. So your answer will become two now because this is another house that will be counted. So house number two is counted and house number four is counted. Okay, then for five, what will happen? The count will become two, and consecutively you have visited two haunted houses, whereas only one was required. So this cannot be included in the answer. So final answer is two. Is the first test case clear to everyone? Yes or no? Strong indices. Okay, you are talking about this one now. Third problem. So yeah, like, you can, as I said, you can apply buying search if you want, right? So yeah, is everyone clear so far with the problem statement, guys? With this particular test case explanation, is everyone clear with the test case explanation here so far? You guys can tell me, then only I'll proceed further. Everyone is clear with this or not, guys? Tell me. Okay. No sir, एक बार फिर से बता दो टेस्ट केस. Which test case? Abhishek Sood, this particular test case. See, in this particular test case, now you have been given the you have been given the edges. So first of all, you will make an adjacency list. When you will make an adjacency list, then what will happen? One will connect to two, one will connect to three, one will connect to four, one will connect to five, like that. And n is equal to one. TCY. N is equal to one. Where n is equal to one? I'm not sure, XD. Uh, There is no test case where n is 1. Right. So yeah, if you will see the next test case, let's go on to the next test case, guys. Okay. So far everyone is clear now. You can give me a +1 again. So far everyone is clear. Then I'll proceed further to the second test case explanation. Okay. So let's say I've been given what 1 comma 2, then what 2 comma 3, then what 3 comma 4, then what 1 comma 5. Then I've been given what 5 comma 6. Let's say. Then what 6 comma 7. Okay. In hidden test case, I don't know about hidden test. I have not seen the hidden test case. I don't have access to the hidden test case. Okay. So yeah, like let's say you have house 1. Now 1 is connected to 2, but I'll take 0 base index. Okay. Because actually the haunted array that is given, it is 0 base index. So when I'll be writing the code, I'll take -1 for every node. Okay. So that I can take them 0 base index. So 1 is connected to 2. 2 is connected to, let's say, 3. Then 3, I guess, is connected to, let's say, 4. Okay. Then 1 is connected to 5. 5 is connected to 6. Then 6 is connected to 7. Something like this. Am I correct? This is the tree that you will make for the second test case, guys. Am I correct? 1, 2, 1, 2, 2, 3, 3, 4. Okay, 1, 2, 2, 3, 3, 4. Then 1, 5, 5, 6, and 6, 7. Looks like that. Right, yeah. So what's next here? Right, so let's check which houses are haunted, which are not. Okay. So whichever are haunted, I'll write H on them. Okay. So first is haunted, second, third. All of them are haunted. So first is haunted. Okay, let me write this using yellow color. So this house is haunted. This house is also haunted. This house is also haunted. Okay. Then fourth one is not haunted. Fifth is haunted. Okay. Then what? Seventh house is haunted. Okay. Right. If this is the scenario right here, so if you will see here, guys, what will happen in this particular question, right? What will happen here? So if you start, right, suppose that if I start from here, so here my counter will be how much? My count will be 1 since this house is haunted. So my count will become 1. And what is the m value given? M value is given as 2. I cannot go through more than 2 consecutive houses. I cannot go through more than 2 consecutive houses. Okay. Like you cannot go then more than 2 consecutive houses, like more than two haunted houses are not allowed. Okay, so count will be 1 here. Then when you will go down here, from if you will traverse, you'll go down here, so count will become 2 here. Then from here when you go down here, so count becomes 3. What will you do, guys? Tell me. If the count becomes 3, okay, are you allowed to go further down or not? Tell me. Are you allowed to go further? Like, is this allowed or not? Tell me, guys. If the count becomes 3, if you have visited 3 consecutive haunted houses and you are only allowed to visit 2, so is this allowed? No, this is not allowed. So this means that you cannot reach this house. Okay, you cannot reach this queen. Okay, then after that, yeah, after that you will backtrack and then you will say that you will run a DFS from here. So here your counter will be 1. Okay, then your counter will be what? Your counter will become 2 here. Now after that, when you go, like when you go from this house to this house, so this house is not haunted. Okay, the house number 6 is not haunted. Okay, you can understand that house number 6 is not haunted. So my count will become what? It will become 0. Okay, because like the status of this house is what? The status of this house is 0. This means it is not haunted. So I can multiply my counter into this. I'll say that it is not haunted. So my count will become 0 here. Now after that, I'll go down. So when I go down from here, then my count will become how much? Then my count will become nothing but 1 here. The moment my count becomes 1 here, right. So I'll say that I've reached the last cell and my counter is under control, right? So I'll say that I'll count this queen. Okay, I can reach this queen. So my answer will be at least 1 here. Finally, my answer will be 1 here. So does this make sense to everyone, guys? Tell me. Is the dry run clear? Yeah, geeks screaming like a girl. Okay, interesting. Right, very good. So yeah, you can say that. I'll take a screenshot of this if you want, right? So let's take a snippet here. Yeah, you can say that, right? So yeah, if the count is greater than 3, assuming that the m value was 2, right? So then geek will do what? Geek will scream like a girl, whatever. Right. So yeah, that's what she said. Let's move forward. And let's try and build this tree here. What is someone saying? Yeah. So far, everyone is clear. Can we write the code? You can write code in the chat. Can we start writing the code now, guys? If everyone is ready for this, okay. And you can hit the like button, okay. Please do one thing before I proceed further, okay. Please hit the like button, guys. Okay. If you're clear so far, please hit the like button. Okay. Yeah. Let's try and move forward now, and let's try and quickly finish this up now. Okay. Because I have to watch IPL as well, right? So yeah, like what you will do here, guys. Okay, firstly, I'll say that I'll make an adjacency list. So I'll make vector int adjacency list of n size. Okay. Then after this, what I'll do is I'll iterate. So I'll say that int I starts from 0, and I guess n edges have been given to me. So n minus 1 edges will be there. So I can say that I start from 1. I is less than equal to n minus 1, because in a tree n minus 1 edges are there, no? So n minus 1 edge list will be there. Now I'll say that u will be what? Let's say u is equal to edges of what? Edges of I0. Okay, the first guy I can consider as u, and then v will be what? Let's say edges of I1. Okay. Now after this, what I'll do is I'll say that adjacency of u, inside that I'll push back what? I'll push back v. Okay. Then after that, adjacency of v, inside that I'll do what? I'll push back u. Okay, this is what we can do. But also one more thing, I can subtract this with 1 and this with 1, because I'm taking 0 base index. Okay, so taking like making the tree 0 based indexed. Okay, so yeah, this is what I'm doing at the very first step. Then I'll mark my answer as what? Initially I'll mark my answer as 0, as simple as that, right? Then I'll say that I'll run a DFS, let's say. Okay, recursive function, let's say. And in this recursive function, let's say initially I'll pass the node 0, because if I'm taking a like 0 base index tree now, so initially my starting node will be 0. Okay, and I'm initially passing its parent as -1. Then I'll pass the m value, that I cannot visit more than m haunted houses, and I'll pass the is haunted array as well. So is haunted array as well I'm passing, and then I'll pass what? I'll pass the answer variable as like I'll pass the adjacency list also. Have I passed the answer variable? I think I have not. So I should, is haunted of 0 is what I'll pass initially, right? And I should also pass the is haunted array. So let's say, yeah, so I'll pass the is haunted array as well. I'm passing adjacency. I should pass the answer array also. So let's say I'll pass the answer array right here. Okay, so I'm passing 0, then -1, like that is the parent, then m consecutive, initially the state of the house. Okay, whether it is haunted or not haunted. So this will indicate basically the counter. Okay, right, then I'm passing the answer, then I'm passing is haunted, I'm passing the answer adjacency. This works fine. Then at the end I can return whatever my answer is, right? So far everyone is clear? You can tell me. So far everyone is clear with this much part? Then I'll write my DFS function also. Okay, you can give me a +1 if you're clear so far, guys. Right, makes sense. IPL. Okay. Indian Paisa League. Uh, yeah. So now after this, I'll write a void DFS function. So let's say what I'll do here is I'll write a void DFS function right here. And in this DFS function, I'll say that I'll have the current node. Then after the current node, I also need to know its parent. Then what? Then I'll pass the m value. Okay. Then I'll pass, let's say, int count. That is the number of haunted houses that I visited, something like that. Then I'll pass int ampersand answer. Then I need to pass what? I need to pass the haunted array. So I'll pass this haunted array, as well as lastly I need to pass the adjacency list. So I'll pass the vector int, let's say, adjacency list. Okay. Right. I hope that this part is clear so far. Right. Any comments so far? No. Okay. So yeah, once this is done, guys, then what will I say? I'll say that if the count becomes greater than m. Okay. So if I visit more than m consecutive haunted houses, then I should return away from there. Correct. Right. Scream like a girl or whatever someone was saying. Okay. Otherwise, I'll say that initially I'll say that I'll mark my flag as 1. Okay. Or what you can say, I'll mark my flag as, let's say, true. Let's say I'll take a Boolean flag. let's say as true. Initially I'll say that I was able to reach the queen. Okay, so let's say I'll take a reach queen variable, basically reach queen variable. Initially I'll mark it as true. Okay, initially I'll assume that I'm going to reach the queen. Okay, if I current queen. Okay, if I'm not, then I'll mark it as false later on. Okay, when I'll be running the loop for the adjacency list. So I'll say that int I starts from 0, I is less than what, adjacency of current dot size. So I'll be iterating through the adjacency list of the current node, then I'll be doing I plus plus. Now after that, what's next? So I'll say that if the what is the connection? So you can say that a connection will be basically adjacency of current I. Okay, this is the connection that I have, right? Basically this is a child that I have. Okay, and if the connection that I have, it's not equal to my parent. Okay, then I'll say that yes, in that case only I'll be running my DFS. If the connection, let's say, is not equal to my parent, in that case only you'll be running, right? Then what can we do next? When you will be reaching the queen, right? So I have marked this like this. Then what can I say? Then I can say that if I am here and I have to try and reach the queen, basically. Okay. So whenever I'll be reaching the end point, right, from a guy, whenever I'll be reaching the end point, so it will be true. So I'll be adding it, right? So yeah, I can say that at the end, if I reach the, like, basically you can say that reach queen, right? Basically, if I'm at the leaf node, so I'll say that at the end, if the, let's say, the reach queen variable, okay, if it is true. So suppose that if I don't, like, it has to be a leaf node, then only this will be true. If it is not a leaf node, then I'll mark it as false. Okay, because right now it is not a leaf node, so I'll mark the reach queen variable as what? This guy is not a leaf node, so I'll mark this as false. Okay, and then I'll run my DFS. But suppose that if I reach, like, if there's a leaf node, then after that leaf node I will not be running any further DFS. I'll not be running any further traversal. So if I reach the leaf node, then I need to update my answer by 1. Okay, so I'll increase my answer here. That's what I can do. Otherwise I'll run a DFS, and I'll say that I'll call for my connection, and I'll pass the current guy as its parent. I'll pass the m value. Okay, after passing the m value, I have to pass the count. I'll check that later on. But yeah, I'll pass my answer. Then what? Is haunted array is also something that I'll pass. Then I'll pass the adjacency list also, right? So these are the basic things that I'll pass here. And now the thing is that how will I pass my counter, right? So what can I do with respect to the counter? So I can say that what can be my counter? So basically, so far, whatever houses I've visited, okay, whatever haunted houses I have visited into is haunted of the connection. Okay, so whether this guy is haunted or not, I can check it like that. So if this guy is not haunted, then my consecutive count will become 0. Okay, otherwise it will be the same, you can say, right, something like that. So this is what I'm assuming. I hope that I've written this correctly. Count. uh, let's say this is the case. So count, let's say before passing only I can check this part. Okay, so let's say if the is haunted is what, let's say if the is haunted of the connection, the guy that I'm going to, okay, if it is 0. Okay, if it is not haunted, then my count will become 0, guys. Okay, consecutive count will become 0. Otherwise my count will increase by 1, so count plus plus. Okay, so then I can pass my counter. Okay, I guess this works fine. Right. So like basically, if I'm at a non-leaf node, so I'll say that I'll mark my queen is reach queen as false, because if I'm at a node which is not a leaf node, then I'll say that I'll not increase my answer. So I need to mark my reach queen variable as false. If I'm going to a connection guy which is not already reached, if I'm going to a child, okay, if I'm going to a particular child such that if this is 0, okay, so if the child that I'm going to, if it is not haunted, okay, then my consecutive counter will become 0. Otherwise my consecutive counter will increase. Okay, and if the reach queen is true, then I'll update my answer. Okay, so let's try and compile it. and check what happens. Okay. So there are several mistakes. Is everyone clear with the process so far or not? Tell me, guys. Everyone is clear with the process so far? Yes or no? With the coding logic, everyone is clear with the coding logic so far or not? Yeah, I have implemented the count here. Na, as I said, this looks better. But yeah, there are several mistakes here. Adjacency of current dot size. Is there any mistake in this part? Okay, so I'll pass it like this. Right. Let's compile it again. Okay, yeah, you are correct. You are basically saying correct. So yeah, in this case now, what I can do is, if I have to do it in a different way, so I can pass a DFS here and then another way here. So if the this is zero, then I'll pass it as zero. Otherwise, I'll say that the new count will be count plus one, because I don't want to impact for other guys. Thanks a lot, haha. You are correct. So if this house is not haunted, then from the next call, this will become zero. If it is haunted, then it will be count plus one. Whatever haunted were there already, plus one to that. Okay. Now what's the mistake? Am I missing something anywhere? What is the mistake, guys? Line number 97. Yeah, this colon is missing in. Yeah. Let's try and run it again and see what happens. Gives me a runtime error. Okay. Why are we getting a runtime error here? Did I not check something? Okay. A missing? Okay. A colon missing. Right. Now I'm getting a runtime error. So let's see what is the mistake. I've declared an adjacency list. That's fine. Then I'm iterating for all the n minus 1 edges basically. Then edges of I 0 minus 1. Then V. That's fine, right? Then I'm inside U, I'm pushing V. Inside V, I'm pushing U. Then I have my answer also declared. Right. So I'm changing the answer variable. Is that a mistake? This is fine, I guess, right? But instead of this, can I make it more easier? Let's say if I don't pass this answer variable, okay. I don't think it's because of this, but still I'm removing it from here. Okay, and I'll declare a global answer variable, let's say. And I'll not pass this here as well, okay. So every time I update the answer as zero, let's say. Let's see what happens here. Okay, the segmentation is still there. So there's some issue in the graph building or something. If you can observe it, you can tell me, right? So yeah, then I need to pass DFS of zero. I'm passing this as one like this and M, and then I'm passing is haunted, initial status is haunted, and then adjacency list also. Then I'll be returning the answer at the end. That's fine, right? So if my count becomes greater than, so yeah, I'm passing this. I'm passing the adjacency also. Adjacency is passed correctly. I'm passing the current guy. I'm passing the parent guy. I'm passing M also correctly. Okay. I'm passing the count correctly as well. Okay. Is haunted is passed correctly. If the count becomes greater than M, then I need to return from there. Otherwise, I've marked my bool reach queen as true. Okay. Then I'm iterating. I starts from 0. I is less than the current dot size. That's fine, right? I plus plus. Then the connection is what? Adjacency of current I, if I'm not wrong, right? And if the connection is not equal to the parent, then what I need to do is I need to mask the reach queen variable as false, because this is not a state. And then I'll call the DFS. When I'm calling the DFS, so I'll call the DFS for the connection, and its parent will be the current guy. That's fine. I'll pass M value as well. That's fine. Then counter will become in future. The counter will become 0. Right. And is haunted array I'll pass. Adjacency also I'll pass. Right. So what is the mistake in this case? Anyone can identify the mistake that I'm making here? Okay. Okay, yeah, thanks a lot. You are correct. I start from zero, I is less than n minus one. Edge list will index of the edge list will be from zero. Thanks a lot. Correct. Yeah, the index of the edge list will be from the index of the edge list will start from zero. No, so that was one basic mistake here. Now it will work fine. Thanks a lot. Thanks a lot. Yeah. Okay. Now the answer is not getting updated. Why? That's another issue. Okay. So what's the mistake now? Let's say I'll start this from zero and less than this. Let's see what happens. Yeah, now it works fine. So yeah, I've passed the answer in this format. Basically, I've passed the answers as parameter only now. Okay, let's submit this. It should get accepted now. Let's see. So yeah, it does get accepted. So is this problem crystal clear to everyone, guys? Yes or no? This was a easy problem, I'll say. It was not that tough, right? So is this clear to everyone? Is there any part which is not clear to you guys? Is the problem clear to everyone overall, guys? Yes or no? Okay, first of all, you declare the adjacency, build your edges. So U and V edges are there. Take zero based indexing. So always subtract minus one from every edge, from every node basically. And initially mark your answer as zero. Initially pass the current guy as zero, parent as minus one, M. Then initially you can pass whether the first guy is haunted or not haunted. If it is haunted, then count will be passed as one. If it is not haunted, count will be passed as zero. Put pass the answer is haunted array, then adjacency also. Then after that, what you can do is you can say that if the count becomes, if you have reached more than m consecutive haunted houses, then you'll return from there. Now what you do is you mark your reach queen variable as true. Okay, then indicating that you are at a leaf node or not. Okay, so if you are at a leaf node at the end, then you'll update your answer that you were able to reach the queen. Okay, now you are at like you will take the connection if your connection if the child is not equal to the parent. So this means that like you can run the DFS, and then you will mark the reach queen variable as false because this node has a child, right? So yeah, this is what you'll do. The current node has a child. If it is not haunted, then next time you'll pass the count as zero. If it is haunted, then you'll pass the count as count plus one. That's what you'll do, and eventually it will work, right? So let me copy this whole code. So time complexity would be order of n, and space would be roughly order of n as well, right? Crystal clear, guys. Understood and enjoyed the session or not? Tell me. I hope that you understood the session and you enjoyed it a lot. Let me share this link with all of you. Right. So yeah, everyone enjoyed the session thoroughly, right? Let me just quickly do a recap. Okay. So the first problem that we did. Okay. The first problem that we did. Let me use a different color. Okay, for today's contest, the first problem that we did, okay, it was basically a greedy problem, right? uh, like the problem was basically based on election, right? Election. Like it was not a greedy problem, it was a basic problem. Basically, the total number of vote that geek gets plus k. Okay, if this is greater than n minus the number of vote that geeks gets minus the number of votes that you manipulate, then geek wins, otherwise not. If you talk about the second problem that we did, right? So second problem was based on binary search on answer. right? So we applied this also. Then after that, the third, like, so you, after the video is over now, you should mention your feedback at the end. Okay, like when the video is over, you can paste your comments. Okay, so yeah, third problem that we did was very easy, I guess. It was 2 pointers, right? It was simple 2 pointers problem, but you can check my code out. I have written it in a clear fashion, right? So it was like a of p minus x, something of this kind, right? Should be this thing, and b of q should be less than equal to a of p plus y, something like that. So we did this also very easily, right? And then after that, the fourth problem. So the fourth problem that we did today was based on graph, like, sorry, tree. So it was a DFS based problem, right? Basic. So I hope that you have enjoyed the lecture thoroughly. You enjoyed everything with me today, right? I hope that I could make your life better, and I hope that I could entertain you throughout the session. I hope that you got as much entertainment and like, yeah, you can see when you will scroll through the chat now. So the codes have been shared, but I'll ask our team to share it with all of you in a link if possible. Okay, that is one thing that we can try. But I hope that you enjoyed the session thoroughly and you understood everything inside out, guys. Okay, so thank you for joining this session. Thank you for doing the weekly contest, and make sure to upskill yourself. Okay, make sure to level up, and I hope that the mistakes that you had made throughout the session, throughout the contest today, you were able to rectify them. I tried checking it, and I hope that I will fix that will be fixed. Test case is not sorted. Yeah, so I'll ask them about it, but basically, if it is correct or not correct doesn't matter. What matters is that at the end of the day, your practice is done and your concepts are getting better. Okay, that is what matters at the end, because it's not about one problem. It's about whether your brain gets more opened or not, whether you are getting better every day or not. Okay, with every problem. Okay, thank you guys, and I hope that you enjoyed. This is me, Yash Dwivedi, signing off now. So make sure that after the video is over, you have to, like, you will comment that you understood everything. Thank you guys. Take care and all the very best. Keep coding, guys. Thank you. Good night.